ECOC 2018, and we're going to do a air-blown fibre demonstration, blowing some MTEL 4 fibre unit around a small tube system to simulate fibre to the home installation. What we've got is an Axel Air 2 machine from CBS, and we have a pan of 4 fibre MTEL blown fibre unit, and we're going to feed the fibre through this guard, and then we'll feed it into the machine, and so that the fibre has minimal drag as it goes through and hits all the edges of the tube system, I'm going to put a small blown bead on the end of the fibre. So I will strip the end of the fibre so that the resin coated fibre comes out of the end of the thermoplastic outer layer. I take a single blowing bead, place the blowing bead on the end of a fibre, and make sure that the plastic goes into the body of the bead. Once the bead's in place, I take a set of crimps and crimp on the bead. Now, as the fibre travels through the tube system, if it hits any resistance or it hits the edge of a straight connector or a junction, that will help it move through smoothly without getting caught. Now I'm going to open up the blowing machine. I've got 2 drive wheels. These will drive the fibre through the system. And I've got a buckle detector, which is a small magnet which holds the fibre in place. When the fibre reaches the end of the system, or if the fibre is caught along the way, the fibre will push back and buckle, and the buckling will move the magnet, and that will cut power to the wheel so it doesn't damage the fibre. So I'm going to take the tube I want to blow into. I've got an end cap on the tube to stop insects and dust and moisture from getting into the tube. I'll take off the tube. I will put a rubber seal on the end of the tube, and then I place the rubber seal into the blowing machine, and it fits inside the O-ring gasket so that air can't escape out of the blowing machine, and the majority of the air is forced into the tube. That air will drag the fibre, or help to drag the fibre along the tube, and also the air pressure in the tube will keep the fibre off the edges, so the fibre will have minimal friction. I feed the fibre into the tube, and I run a little bit of fibre along. Then I place the fibre along the channel, and then I open the wheels with this handle, and I place the fibre in between the drive wheels. And then it's very important here that the fibre is free to move through the machine, and the fibre isn't stressed or pinched by any of the metal parts, because if the fibre is damaged, it won't run through smoothly. Now I'm very carefully going to clamp down the tube and then close the lid. And as I close the lid, I check that the fibre can still free run inside. If the fibre is pinched, I won't be able to move the fibre. Then I must lift up the lid, cut off any damaged fibre, bring the fibre back, put a new bead on, and start again. As I close down the lid, I've got to keep the pressure in the machine, and I want the majority of air running at about maximum of 10 bar for this demonstration to run through the tube and not to escape out. So I need a tight connection on the lid, but not too tight. So I just test the fibre by pulling back a few centimetres, and I'm happy that the whole thing is moving. Now on the machine, I've got a control box, and here I can control the torque of the wheels and the speed of the wheels. I can also read the distance and the speed that it's running, and it will run between probably 30 and 40 meters per minute. I've got a pressure gauge on the blowing machine, and the pressure gauge will run up to around 15-16 bar. We have an electric compressor, and that electric compressor will give me a maximum of 10 bar. These products generally will work up to 15 bar for the outdoor products, and then the indoor products or any stripped tube will have a maximum of 10 bar. So when I'm blowing externally, I can blow longer distances. When I move into the home, into the multi-dwelling unit, I'll normally move on to a low fire hazard product, and then I'll go down to 10 bar. However, the distances are much shorter. So I'm all connected up. The first thing I do is I run fiber into the tube. When I pressurize the box, the air will run into the chamber, and it will have the effect of pushing against the fiber. So I want to run fiber into the tube system before I introduce air pressure. Otherwise, I'm trying to force the fiber against the edge of the connection. I want the air to force the fiber down through the tube. So I'll start off just by running the wheels slowly. And you can see now the fibre is running through without any air pressure. We could do this for quite a distance, but what I want to do is, as soon as I'm running fibre through and it's moving, I start the air pressure. I can control the air pressure here with this dial, and I can monitor it. And what I want to do is just have enough air pressure to keep the fibre moving. I can hear the air building up, and it's running to about 4 bar. Okay, so it's all moving. What I'm going to do now, I'm going to let the air pressure off, and then I'm just going to put in a unit at the end so that I can catch the end of the fibre. And we're going to run the fibre through to the home, and when it comes through to the home, I'm going to stop, move back on, and once the fibre is running out, I'll run about 10 meters, 15 meters, and then we'll stop the machine. Then we will fibre splice, manage into the tube, connectorize. So now we're up and running. I'll turn the air back on. Yeah, it's moving about 24 meters per minute. It's quite a short run, so we won't try and run it too fast. If you look at the drum now, you can see the fibre running through the drum. And it's up now to 37 meters per minute. If it encounters problems on the way, rather than trying to run the fibre through as fast as possible, we can increase the pressure or decrease the speed as long as it keeps moving. If we have a blockage, we would need to reset the sensor. Then we would normally try and pull back the fibre slightly and then re-blow. As it hits a blockage, pulling back the fibre, introducing more pressure will often allow it then to move past the blockage. Normally, blockages occur wherever we have a connector. Now we've run through the drum, you should see the fibre coming through. And at the end, it hits an air stone. The air stone stops any debris and it stops the fibre coming through, but it allows the air out. When it hits the air stone, I will get a force backwards along the fibre buckles, and it automatically stops. So it could be a one-person operation. You can get an air stone that has a sensor on board with a GSM unit, and it can send a message to your mobile phone to say the fiber's arrived. but I can read this from the machine. The machine's got an electrical buckling detector. I could also have on some machines an automatic clutch that registers the pressure on the wheels, and it will stop automatically when the wheels begin to labour too hard. When I'm finished, I will turn off the air. I will let the pressure go all the way down to 0. Once the pressure has gone down to 0, I'll be able to take off the air stone. There is the fibre. What I will do now, I will take down the pressure a little bit, take down the speed, reset the sensor, start the pressure again, and I'll control the fibre with my thumb and my forefinger, and control the fibre with the wheel, and then I'll start the fibre. I'll run through enough fibre to splice. So I just put in enough fibre to put onto my management system. And bring the speed down to 0, so that's my fibre. Turn off the air. Now the fibre is ready for splicing, and what I would do is I would take the end of the fibre, and you can see the buckling on the fibre. I would take the fibre all the way back till it's nice and straight and it's not been under too much stress. Cut that fibre away, strip back, take the primary coated fibres out, the resin that they're coated in, and then make the splice. If it's going into a building, I'd need a gas block connector for any underground tubes just to stop the air from going in. If it's not going into a building, I might want to put a water block connector on the end so the fibre comes out of the tube but water can't come in or out of the tube to contaminate. And that's the demonstration concluded. Thank you very much.